All right, let's dive into something that feels like it could really shake things up in how we write code. OpenAI has introduced a new tool, and they're calling it a cloud-based software engineering agent. Its name is Codex.
Yeah, and looking at the material you shared, recent announcements from OpenAI, tutorials, and accounts from people who've actually been using it, it's clear this isn't just a souped-up autocomplete. This is powered by a new model, Codex 1, specifically tuned for software engineering. And the big promise seems to be letting engineers accelerate significantly, allowing them to move a lot faster, as they put it.
Okay, so our mission today is to truly get to grips with what Codex is. How do you even interact with it? What specific tasks do people see it handle in these sources, the really impressive ones, maybe some less than perfect attempts? And critically, what might this tool mean for the way you, as a developer, approach your daily work? Let's unpack it.
Absolutely. At its heart, Codex is envisioned as an AI agent, capable of handling engineering tasks more or less on its own.
An agent, right? That keyword suggests a higher level of autonomy than just like a suggestion box. How do you actually get your hands on it?
Well, the information points to two main avenues right now.
Yeah.
Um, there's an integration built directly into the ChatGPT interface. You'll find that if you're on a pro, team, or enterprise plan currently, they say plus and ADU users are getting access soon too.
Okay.
And then there's a separate command line interface, the Codex CLI. That one's open source
Yeah.
if you prefer working from the terminal.
So you've got the familiar ChatGPT web experience or a more direct terminal route. But either way, it's not running locally, is it? It's executing remotely.
Exactly. It's in OpenAI's cloud environment,
Hmm.
which is a key point. And it ties into one of its major selling points that really stood out in the material, the ability to work on many tasks in parallel.
Ah, yes, this idea of asynchronous delegation. You're not sort of pair programming with it line by line. You give it a chunk of work and it goes off to do it in the background while you potentially do something else.
Precisely. It's a shift in how you interact. One user had a great analogy for this, calling themselves the CEO who delegates tasks to AI employees. They even quipped about essentially hiring a senior software engineer for just $200 a month.
Wow. That definitely makes you pay attention. And being asynchronous means you could theoretically tell it to fix a tricky bug and start adding a new feature and maybe draft some documentation all at once.
That's the idea. It's designed to free you up by tackling these things concurrently in separate environments.
Okay, that sounds powerful, but how does this AI employee actually operate on your code base? What's the setup like?
Well, the primary connection is to your GitHub repository. You authorize Codex to access it, that sort of thing. When you assign a task, it creates its own cloud sandbox environment. This sandbox gets preloaded with a copy of your code.
Right, a sandbox. And I noticed a detail about the sandbox. It's secure, isolated, and interestingly, internet access is disabled during task execution. Why is that?
Correct. That isolation and lack of external network access is a crucial security measure. Makes sense, right? Inside that sandbox, Codex can read and edit files, and importantly, it can execute commands against your code copy. Things like running test harnesses, linters, and type checkers.
So it's working in a safe, contained space, testing its own changes before it even proposes them back to you. What else helps guide it? Is it just figuring things out?
Well, there's a really interesting feature mentioned, an optional but apparently highly recommended file called agent.s.md. This is just a plain text file you put at the root of your repo.
Agents.md. Oh.
Think of it like a set of instructions for the agent. You can tell it about your coding conventions, how to run specific tests, maybe any quirks of your project. It's essentially prompt engineering baked right into your repo structure.
That's clever, providing custom guidance right alongside the gem. It almost reminds me of, there's this technical trick one user highlighted, changing the G in a GitHub URL to a UHub. It apparently gives you a raw text file of the code and a token count. They use this, which even has an API, they said, to programmatically pull code context for more automated prompting workflows.
Yeah, that UCUB trick is a neat hack, isn't it, for getting code context programmatically.
Yeah.
Definitely useful if you're building tooling around code analysis or, like you said, prompting.
All right, so with that understanding of how it works, let's get practical. What kind of real-world coding tasks did people actually see Codex handle in the sources you looked at?
Well, the range is pretty broad. We saw examples of it writing new features, answering questions about the code base structure, which is handy for onboarding,
Yeah, definitely.
fixing bugs, drafting pull requests, refactoring code, renaming things, writing tests, and even starting documentation.
Okay, give us some of the standout examples. What were the moments where you thought, okay, that's genuinely impressive?
Well, right out of the gate, just connecting it, it can analyze your code base and suggest initial tasks itself. Things like explain code base structure or find and fix bugs. One user saw it immediately catch and remove a duplicate import and fix a subtle logic error they described as returning a duplicates. Simple things maybe, but auto-detected.
Fixing minor things proactively is a solid start, for sure. Less noise later.
Definitely. A more complex example involved refactoring. Someone approved a task to move the styles from HTML to a dedicated CSS file. They mentioned Codex completed this in just the time it took me to make a cup of tea.
Seriously, for moving all the style.
Yeah, and it wasn't a trivial change either. It added over 500 lines and moved over 600 lines of code.
Wow. A significant refactor completed while you waited for your coffee to brew.
That really highlights the asynchronous speed, doesn't it?
Exactly. And another striking example was adding a feature. A user wanted to make their web app mobile responsive. Codex took on the task, and they reported in literally 2 minutes and 49 seconds, the app was updated to be significantly more mobile-friendly. 2 minutes 50. For mobile responsiveness, that's remarkably fast.
Yep.
That kind of work can often be really fiddly.
It really shows the potential for speeding things up. And the demonstration of the Codex CLI included a fascinating multimodal example. This is pretty cool. The agent was shown a screenshot of the Mac photo booth app.
A screenshot, not code.
Right, an image. And then it was tasked with implementing a similar filter interface on the web using the user's webcam. It basically reasoned about the image and then wrote the necessary web code.
Okay, coding from a picture, that's not something you typically expect from a code assistant. That's different.
It suggests a capability to understand intent from various forms of input, doesn't it? Another user noted how Codex handled a failure gracefully. When OpenAI's safety system rejected an image generation request the user made through their app, which Codex had helped build,
Okay.
Codex correctly processed that rejection within the application logic, ensuring the user didn't lose their credit for the image generation. It demonstrated an understanding of the broader system flow, not just isolated coding.
So it's aware of context beyond just the code itself. That's important.
Yes. And we saw it tackle more complex changes involving multiple files. One user asked it to change the chat input color based on chat agent mode. Now, this required modifying a UI component, type definitions, and probably other dependent files.
Right, those kinds of changes ripple through.
Exactly. And Codex successfully identified and modified all the necessary parts of the code base. It showed an awareness of how different files relate to each other. Even if, in that specific case, the linter test failed initially, it knew where to make the changes.
So it's understanding the code base structure, not just isolated files. That's key.
Right. And it can even perform investigation tasks, like digging into search result ranking logic within a large code base, or determining if a specific field exists in a complex data structure used by the search functionality.
So it's not just writing code, but also reading, understanding, and analyzing it at a pretty deep level. These examples collectively paint a picture of a tool capable of handling a surprisingly wide spectrum of typical development tasks, and often doing so very quickly.
That seems to be the takeaway, yeah. And on that note, one user shared a really insightful workflow for automating how tasks get sent to Codex. It shows how people are starting to build systems around these AI agents.
Oh, interesting. Walk us through that. How did they integrate Codex into a broader workflow, automating the automation?
Kind of, yeah. This setup was triggered by approving feedback requests that were managed in Airtable.
Okay, so feedback comes into Airtable, someone reviews it, clicks approve, and then what happens?
Right. The approval in Airtable triggered a Zapier automation. Here's the sequence they described. First, the Airtable record gets marked approved. Zapier detects this. Then, crucially, Zapier pulls the relevant code context from the GitHub repo. They mentioned using that UThub trick we talked about, or maybe the GitHub API to get the code snippet the AI would need.
Okay, getting the context automatically. Smart.
Then, Zapier sends the original feedback and the fetched code context to another AI model. In this case, they used Google Gemini 2.5 Pro.
Hold on. They're using one AI to prime the task for another AI, like an AI preparing work for another AI.
Exactly. Gemini, following specific system instructions they gave it for this workflow, takes the raw feedback and the code context and generates a highly structured, optimized, enhanced prompt, specifically tailored for Codex. These instructions apparently told Gemini to focus on defining a single task with a clear location and goal.
Wow.
Then Zapier updates the original Airtable record with this precise AI-generated Codex prompt. And the final step. Zapier formats this prompt, URL encodes it, and creates a special URL. This URL links directly to the ChatGPT Codex interface with the prompt already pre-populated in the URL itself.
So the user just clicks a link.
The user just clicks this magic link from their Airtable record, lands in the Codex interface with the perfect prompt ready to go, and just clicks code.
Wow. That is taking automation to another level. It's not just delegating the coding task, it's automating the prompt engineering process itself using another AI and then creating a one-click deployment method into the agent interface. That's quite something.
It really highlights how users are starting to build sophisticated systems, doesn't it? Leveraging multiple tools and AI models together to make these agents maximally effective. It also underlines just how important well-structured prompts are, which, again, is what that agents.md file is also designed to facilitate, just in a more manual way.
Okay, fascinating workflow. So the agent finishes the task, makes changes in the sandbox. How do you actually review what it's done? How do you know if it worked correctly?
Codex provides verifiable evidence, as they call it. It commits its changes within the sandbox environment and gives you citations of terminal logs and test outputs. You can literally see the commands it ran, like running your test suite, and see the results right there in the interface.
So you can inspect its process and the outcome of its test within its isolated environment. That gives you a lot more confidence than just getting a block of code thrown back at you.
Absolutely. However, and this is really important to stress, as the sources do repeatedly, this is a research preview, it's still early in its development. While it aims for human-quality code and provides those test results, they emphasize that it is essential for users to manually review and validate all agent-generated code before integration and execution.
That makes total sense. It's a powerful assistant, maybe, but you're still ultimately responsible for the code going into your project. What are the next steps once you've reviewed? Can you ask for changes?
Yeah, the interface lets you review the proposed changes. You can request revisions from Codex based on your feedback. Or if you're happy, you can directly create a GitHub pull request right from the interface. One user was visibly excited about how quickly they were able to generate several PRs for their actual production code base using this flow.
Pull requests straight from the AI's work after review.
Oh.
Were any performance benchmarks mentioned in the sources? How does it stack up?
Yes. They did cite some benchmarks like SWE Bench Verified and also their own OpenAI internal SW tasks. They showed the Codex 1 model performing strongly on these coding tasks, often coming out slightly ahead of other models like O3 High, according to their data.
Okay, performs well. What about safety and security? It's modifying code, potentially in sensitive repositories. That feels like a concern.
They definitely address this. As we touched on, running in that isolated container with internet access disabled during execution is a core safety measure. They also mentioned that it was specifically trained to identify and refuse requests that appear intended to develop malicious software while still trying to support legitimate low-level coding tasks. And they highlight that rigorous safety evaluations are ongoing.
So they're trying to build in safeguards. But are there limitations or, rough edges people encountered? It can't be perfect yet.
Definitely not perfect. It's a research preview. They stress that. Tasks can take time anywhere from a minute up to 1 to 30 minutes, or even longer for really complex jobs, apparently. The whole delegation model is different from interactive coding, which is a change users need to adapt to. It's not instant back and forth. And occasionally, environmental issues can pop up in the sandbox itself, like a linter or a dependency not being found correctly, which might cause tests to fail even if the code changes themselves are actually fine.
Okay, so debugging the sandbox environment might be a thing.
Potentially, yeah. It absolutely requires human oversight and review of every single output, no question.
It's a powerful tool, but you still need to be the engineer in charge.
Got it. How are real companies and developers using this right now, based on the sources? What are the early use cases? Well, OpenAI's internal teams are apparently using it to offload repetitive tasks, things like refactoring and writing tests. The goal is allowing their engineers to stay focused on higher-level design and more complex problems. External testers mentioned included companies like Cisco, Temporal, Superhuman, and Kodiak. They're exploring it for accelerating feature development, debugging, writing tests, and even refactoring large legacy code bases. And one particularly interesting use case mentioned was enabling non-engineers like product managers or designers to draft simple code changes.
Simple changes, like what?
Like text updates or minor style tweaks, things like that. An engineer can then quickly review and approve them, freeing up engineering time from those small, interruptive tasks.
That really speaks to the paradigm shift idea we mentioned at the start. It sounds like the developer's role might evolve quite a bit with tools like this.
That's certainly the vision OpenAI puts forward. They see developers choosing what parts of the work they want to personally own, the creative problem solving, system architecture, the really complex logic, and then delegating the rest to agents. The goal is significantly higher productivity and speed. They believe this asynchronous multi-agent workflow that Codex enables could become a standard way engineers operate, complementing the real-time coding tools we use today, not necessarily replacing them entirely.
It does paint a picture where the developer becomes less of a direct code typist, perhaps, and more of a manager, an architect, and definitely a reviewer of AI-generated work.
That seems to be the direction the capabilities point towards, yeah.
Okay, so to sum things up then, we've seen that OpenAI Codex is introduced as a pretty serious AI engineering agent. It seems capable of handling a wide array of coding tasks autonomously, from refactoring existing code and fixing bugs to adding features, and even helping you understand your own code base. It works asynchronously in these secure, isolated cloud environments, connects to your GitHub repo, runs tests, and can propose pull requests. And early users are already leveraging it to delegate tasks and potentially accelerate their development speed quite significantly.
Absolutely. And while it's clearly presented as a research preview, requiring careful manual review, the examples and workflows we saw, especially that automated prompting one, demonstrate significant potential. Potential to change developer practices, boost productivity, and maybe even enable new approaches to automating parts of the software development lifecycle.
It certainly feels like a tool that pushes us further into a future where working alongside AI agents is a fundamental part of how we build software, doesn't it?
The capabilities described really suggest exactly that. It feels like a step in that direction.
So that leaves us with a thought for you to consider until our next deep dive. If AI agents like Codex can increasingly handle the more routine or time-consuming coding tasks, what skills should developers focus on cultivating to thrive in this new environment? Is it prompt engineering, system design, reviewing skills? And looking ahead, what kinds of ambitious projects might suddenly become feasible for individuals or small teams when this level of automated engineering assistance is within reach? Something to mull over.